Procedure for decomposition reaction. Take about 2 grams of ferrous sulphate crystals in a dry and clean boiling tube. Hold the boiling tube in a test tube holder. Introduce the boiling tube into the non-luminous Bunsen burner flame such that the mouth of the tube is neither pointing towards you nor the fellow students as shown. Adjust the Bunsen burner or gentle flame. When tiny droplets of a colorless liquid settle near the neck of tube, test the liquid with blue litmus paper, red litmus paper and cobalt chloride paper. When steamy fumes stop coming, heat the test tube strongly for few minutes. Smell the gas or gases evolved, if any, by gently wafting them towards your nose. Test the gas with acidified potassium dichromate paper and moist blue and red litmus paper. Note the color of the residue in the boiling tube. Observations. Crystals of ferrous sulphate are light greenish in color. When boiling tube is gently heated, steamy fumes are given out. These steamy fumes condense on the cooler parts of the boiling tube, that is, near its neck, to form tiny droplets of a colorless liquid. When the blue litmus paper is touched with the droplet of the colorless liquid, it shows no change in color. When the red litmus paper is touched with the droplet of the colorless liquid, it shows no change in color. When the cobalt chloride paper is touched with the droplet of the colorless liquid, it changes to pink color. When boiling tube is strongly heated, the ferrous sulphate crumbles to form white powdery mass and gives off colorless gas which strongly fumes in the air. The white powdery mass starts changing to reddish-brown color. When the gas is gently wafted towards the nose, it smells like burning sulphur and causes a sensation of coughing. When acidified potassium dichromate paper is held in the gas, its color changes from orange to green. When moist blue litmus paper is held in the gas, its color changes to red. When moist red litmus paper is held in the gas, its color does not change. When the gases stop coming, the color of residue is like rust, that is, reddish-brown. Conclusions. Crystals of ferrous sulphate are light greenish in color. The steamy fumes are that of water of crystallization. On heating, water of crystallization breaks loose from the crystals and then changes into steam. The steam liquefies on the cooler parts of the boiling tube to form tiny droplets of water. The colorless tiny droplets of the liquid is water. It is because these droplets are neutral towards the red and blue litmus, but turn cobalt chloride paper pink. 2FeSO4 7H2O light green and solid on heating form Fe2O3 solid reddish brown plus SO2 gas colorless plus SO3 gas colorless but fumes strongly in moist air plus 14H2O gas, water of crystallization in the form of steam. The sulfur dioxide gas has a pungent and choking smell like that of burning sulfur. It causes coughing sensation. The gas fumes strongly in moist air because sulfur trioxide gas dissolves in water vapor to produce sulfuric acid mist. As acidified potassium dichromate paper turns green, it confirms that steamy vapor contains sulfur dioxide gas. As moist blue litmus paper turns red, it confirms that steamy vapor is acidic in nature. As moist red litmus paper does not change in color, it implies that steamy vapor do not contain any alkaline gas. The residue in the test tube is ferric oxide, Fe2O3, which is reddish brown in color. To sum up, heating strongly the ferrous sulphate crystals is a decomposition reaction because a single chemical compound breaks into these simpler substances, that is, ferric oxide, sulfur dioxide and sulfur trioxide. Furthermore, it is an endothermic reaction as it proceeds with the absorption of heat. Very important note: breaking of water of crystallization from ferrous sulphate, FeSO4 7H2O, is not a decomposition reaction on account of the following reasons. A decomposition reaction must produce two or more different chemical substances. In this case, FeSO4 7H2O just splits to form FeSO4 and H2O and no new chemical substance. Therefore, it is not a decomposition reaction. FeSO4 and H2O can be recombined to form FeSO4 7H2O. So the separation of water of crystallization from its chemical salt is a physical change and not a chemical change.